Friends, hello and welcome on techguruspeaks.com. Today I would like to consider one of the most important modules of Python programming, that is called SciPy, which stands for Scientific Python. SciPy is basically an open source Berkeley software distribution, that is called BSD, licensed library for mathematics, science and engineering applications. This module depends on NumPy. That means it is built on top of NumPy. Based on NumPy module, the SciPy module has been developed. And it provides a large number of functions that operate on NumPy arrays and are very useful for performing operations like scientific and engineering applications. It's a full-featured version of linear algebra, while NumPy contains only a few features, because I have told you, like, SciPy is built on top of NumPy. That is why it will be having more features than NumPy. SciPy also offers many user-friendly and effective numerical practices like techniques for numerical integration and optimization. Most new data science features and techniques are available in SciPy rather than NumPy, because SciPy is a relatively new module compared to NumPy. So now I'll be moving to the demonstration part that will be done by using one of the most popular IDEs for Python program development, and that is called Spider. So let's move to the Spider IDE for program demonstration. So for demonstrating scientific Python, that is called SciPy, I have used here three programs like SciPy01.py2, SciPy03.py. Three programs have been written here to demonstrate the different operations that is made available with SciPy. Now, in order to perform them, first I need to import the necessary modules. I have already told you, like, NumPy will be considered as the older module because it comes before, better to say it came before SciPy, and based on NumPy the SciPy module has been developed. Okay, so first I'll be using some of the modules that is needed for this particular program demonstration. So as I have told you before, like, since SciPy is depending on NumPy, so I need to import NumPy as well as SciPy. Okay, and from SciPy module I will be importing this particular class. Basically it is related with linear algebra. So here my objective is to solve for x and y for the set of equations 5x plus 3y equal to 21 and x plus y equal to 5. Okay, so now I am going to create the input and solution arrays. So A is denoting here the input array and B is denoting here the solution array. So in that way I have created A and B. Just let's check it whether it's okay or not. So they have been created successfully. So basically I have told you 5x plus 3y equal to 21, so that is why 5 and 3, so it is 5x and it is 3y. Next is x plus y, so 1 and 1, because it is having the coefficient values as 1 and 1 for x and y respectively. So in that way the input array has been created, and now this is the solution array, so it will be having the values like 21 and 5. So in that way the initial arrays, one is the input array and one is the solution array, has been developed by using np.array. That is a good old technique to be employed. So now I have created the needed arrays. Now I am going to apply the the linear algebra class and its method, that is called solve. So I have already told you, say I have already imported this particular class from scientific Python. So here both of the modules are needed. So the solution has been given here, that is x equal to 3 and y equal to 2. So that is the solution. So that is also commented here. So by using the solve function of the linear algebra, that is linalg class, and that is a class name, and solve method of this class, we have been able to provide the solutions for the setup equations that has been mentioned over here. So that is the beauty of scientific Python. So by using this particular module, we will be able to provide solutions for linear algebra. Okay. So now I am going to consider the second program. So here first I am going to consider, already I have imported the NumPy module. Now I am going to import the remaining modules because it has been mentioned in the second program. So because they will be needed for the program development. So first I will be trying to create a square matrix, because on the square matrix I am going to apply several mathematical operations. So just I need to check whether it has been created or not. Yes, the operation was successful, it has been created successfully. Now I am going to create the determinant of this particular matrix that has been created just now. Okay, it is the matrix that is created just now. So it is creating the determinant for this given matrix. Now I would like to calculate the inverse of the given matrix. Again I am using the same, say, class that is called linalg that I used earlier for the, say, finding the solutions for x and y for a given set of equations. So using the same class from the SciPy module, I am basically doing what I am doing, basically the operation that is the inverse operation that can be applied on a square matrix that was built or developed earlier. So now I would like to create the singular value decomposition that is called SVD. Again I am using the same class that is linalg, and here the name of the function is SVD, that is used for calculating singular value decomposition. So it is showing the result here. Next I will be trying to generate the lower upper decomposition that is called LU decomposition. Again I will be using the same class here, but the method may be different. Like here I have used SVD method, now I will be using the LU method. So all these methods are part of the same class that is called linalg. Okay, now I will be performing some kind of operations which is related to the polynomial. Say for example I am having the coefficients, that is a list of coefficients. So it has been created. Now I have say used this particular, it is a basically a kind of class which is part of the NumPy module. Now here I am doing what, I am now just going to apply this code statement. So now I am going to execute this statement. So if I am printing this thing, okay, so that is basically generating what, that is generating the value of the polynomial for p equal to 5. Okay, so that is the idea. So in that way the poly 1D class can be applied. So basically it is applicable to a polynomial, and we have been able to calculate the polynomial for x equal to 5. So using poly 1D class I have done this. Now I am going to basically perform the idea which is basically related to the integration. Clear? So here I am going to apply the integration operation on x square while the lower and upper limit being 0 and 4. Okay, so just I am going to apply it here. So if I am printing this thing, it will be showing the result. So that is the idea. So here I have say run them sequentially, like individual code statements are being run here. I can also run the thing like as a program like this. Clear? So then you can see the thing also, like what is the polynomial being generated here. Like here I have been following the idea of running a particular code statement of the program one by one, but here if you run the program as a whole, like as a complete program, you can see the corresponding polynomial also, like here 5327. Okay, so these are the values being passed as the coefficients. So 5x cube, then comes 3x square, then comes 2x plus 7, that is the polynomial. Okay, and now we have put here the value of x as 5, so that has been applied over here, and that is why you are basically generating this kind of result. So that is the idea being employed. So if you just run the program as a whole, you will be able to see the polynomial. That is the idea. Okay, so hope you have understood the logic of this program, and lastly it is a result of the integration. Next comes, we are going to apply here some special operations on different say numeric values. Say for example I am going to apply here the cube root. So here what is the name? The name of the class that has been imported from the SciPy module is named here special. Okay, so if I am now writing this like special.cbrt and the values that from that actually we are going to generate the cube root. So it will be shown like 5 cube 125, 4 cube 64. Now we are going to define exp10 function, that is exponent 10 function, and pass it as an argument. So that can also be done here. Just have a look at it. So if I am writing here exp, so that will be shown over here. Okay, now I am going to perform the permutation and combination operation on different number sequence like this, like it is basically called 6p4. Okay, so if I am writing here the variable name, and it will be showing the value of permutation, that is 6p4. Similarly I can also apply the combination. So that is the idea. So I can have the value of n and r as n equal to 6 and r equal to 4, so that is ncr. So basically it is 6c4 and it is giving you the value 15. So that is the idea of applying combination. Okay, and lastly I would like to perform log sum exponentiation function on it. It is the example of log sum exponential function. So just have a look at it. So if I am just writing the variable name, it will be showing the corresponding value. This thing can be run as a program also by using this button that you have seen earlier also in my previous tutorials. So that is the way to demonstrate the scientific Python module and different operations that is part of it, like different operations that we have applied till now, which are part of the scientific Python module that is called SciPy module. So I hope that you have understood the basic concept of this module, and I also hope that you will be able to apply these particular functions on your scientific or engineering applications. In that way your applications will be more enriched. Okay, so I think that you have watched my video thoroughly and tried to understood and basically tried to understand what's going on here. And if you like this video, please don't forget to subscribe to my YouTube channel. So here comes my URL of my YouTube channel, and this is the URL of my website, and finally I have got the official email ID. Have a nice day. Thank you very much.